Okay, now let's talk about the limits of solution architecture on AWS. What if you had to handle an extremely high rates of request on your infrastructure? So let's have a look. Route 53 is a global DNS service, and it's meant to handle in extremely high rates of requests. So you are fine at this stage. You can handle client, also do some client caching, so to save some data. And has been requested from your APIs in order to save request going into your infrastructure. But if your request goes into your infrastructure, for example, through CloudFront, then then CloudFront also has caching capability, and you can achieve easily 100,000 requests per second on the CloudFront. CloudFront has reduction origin, and the origin can do many things. But let's took an example with the ALB or API gateway. So if you are using an ALB, application load balancer, it can scale tremendously. Okay, and the ALB has to have warm up issues, but not anymore. It can now scale seamlessly. The API gateway has a soft limit of like 10,000 requests per second, as we have seen, and also the API gateway has some caching capability, so there's a chance to stop requests at this stage. Okay, the compute layer within the different options, if we are using an ASG or ECS or EC2, it's going to be slow. You are going to have to bootstrap your instances after your VMs are created, so this can take a lot of time to scale, but this still scales well. It's just going to be a little bit slower. And if you are using Fargate, it's Docker container that have to be booted up, so it's going to be quite quicker to scale. So they have launched onto AWS Global Infrastructure, so it may be a little bit faster to scale, and will still work with your architecture. And if you are using Lambda for your compute layer, then you can get up to around 1000 concurrent execution for your Lambda functions in your region. But this can be increased as well. Just contact the AWS support for the resource limit increase. So this is a soft limit, but it's good for you to see these numbers and just to get understanding of the capability of each side. So as we can see in the compute layer, we don't have any caching capability. So now we have a database layer, which is our data. Our data is going to be in RDS, Aurora, Elasticsearch. Okay, and these are going to be provisioned database, provision a lot harder to scale, except maybe Aurora. AWS will disagree with me, but still you have provisioned a capacity of your database side. If you are using DynamoDB, then you are in luck, because you can use auto scaling, on-demand scaling, and so you can enable a much higher read and writes. And if you need some caching capability for your data, then you can have Redis. You can scale up to 200 nodes, memcached up to 20 nodes, in charting or DynamoDB, DAX up to 10 nodes. So that are primary and replica. Okay, so that's going to help cache your DynamoDB queries. What if you need to store data on disk? Okay, so then in case you are using EBS drive, Elastic Block Store drive, then you get up to 16,000 IOPS on GP2, 64,000 IOPS on IO1, and 256,000 on, and it has something some caching capability. That means that you can cache data if you wanted to onto an EBS volume. That is, if that is a very common pattern. If you are using instance store, you get millions of IOPS, so much higher IOPS rates. And again, your instance stores can be used as a local cache for your EC2 instance. For EFS, it's a bit different, because you are sharing file across many instances, in which EFS Elastic File System, in which case you have two different performance mode. General, in which we get more performance, and the more files we have onto our EFS network file system, or we can enable the max IO or provision IO on EFS, in which we are saying, okay, we want more IOPS than the number of files we have, so please enable that. Okay, finally, if we need to decouple our application, then SNS and SQS virtually have unlimited scales, so we are fine. SQS FIFO have about 3000 requests per second with batching, or 300 requests per second without batching. And can you something can you say something that you have to provision, and for each chart you provision, you get about 1 megabyte per second in 2 megabyte per second out per chart per shard. So in the kinesis, and for each shard you can you provision, you get about 1 megabyte per second in, and 2 megabyte per second out of per shard. Okay, regarding the static routes, we can also have CloudFront is at the edge, and we can use S3, and S3, as we've seen, the main lines of performance is 3500 ports and 5500 gets per prefixed per second. Okay, and the second and the KMS limits will be problem if you are using SSL KMS encryption, in which you will be limited to 10,000 calls on KMS, for example, per region. Now this is a number that changes based on the region you are choosing, but I just want to give you some idea that KMS will be a limit for your S3 performance. And obviously you can have your EC2 instance where your compute layer also talk to S3. It doesn't have to be through CloudFront. So one which you notice is that the more we are going on the right hand side in this architecture, the more it's going to be expensive. So the earlier we can cache the request, the less expensive is going to be for us. So all the things we can have to do with this is caching on the left hand side. Maybe deal with TTL, understand all the network calls that have to be made. If we have to go all the way to the right, understand the computation that need to happen, the cost of these computations that need to happen, and also the increased latency from going and propagating a request all the way to the right. So this is a high level solution architecture discussion, but it's really important for you to see all the limits of AWS into one slide, and just so you understand why caching is so important, why it's so much better to treat the requests at the edge versus treating them at the very deep parts of your architectures, and why caching can be made in so many different places. Okay, so that's it for this lecture, and I hope you liked it, and I will see you in the next one.